And during the course of the studies of interference, you will come across what is known as optical path. Imagine two beams of light in which one passes through air whereas the other passes through a different material having a refractive index mu. And let t be the time taken by the beam to travel a distance d through the material. And during this time, the beam traveling in air moves through a distance which is known as the optical path. The equivalent distance traveled by a beam of light in air is what is known as the optical path. Now you can look at the figure. The time taken by light to travel a distance d, that is t equal to d by v, where v is the velocity of light that is traveling through this material. The equivalent distance traveled in air equal to c into d by v, where c is the velocity of light in air. But we know that c by v is what is known as the refractive index of the material mu. Hence, the optical path or the equivalent path is equal to mu into d. So what happens is, if a ray of light travels through a material medium through a distance d, then the equivalent path traveled in air is what is known as the optical path. It is given by the product of the refractive index of the material and the distance traveled by light through the medium.